Hey there. Today, we're going to unpack the three core goals of behavior analysis. Now, I know these might sound like dry academic terms, but trust me, they're really more like a powerful blueprint that scientists use to understand, predict, and, actually influence behavior for the better. So let's get right into it.
So, have you ever really stopped to wonder how we go from just watching a behavior to being able to reliably change it? I mean, it's not magic, right? It's a system, a process. And that's exactly the journey we're going to take today. I think the best way to picture this whole thing is like a ladder. Each rung we climb takes us to a deeper, more powerful level of understanding. We're going to start at the bottom with description, then climb up to prediction, and our final stop is the very top rung, control. So, let's take that first step. All right, first up is level 1, describing behavior. This is all about seeing the what. What is actually happening, with zero interpretation or guesswork thrown in. And notice that word, objective. It is absolutely everything. This is the bedrock of the entire science. It's about collecting facts, not feelings. We're not asking how someone feels about what they're doing. We are laser focused on the cold, hard, observable data of what they actually do. To make this really click, think about a meteorologist. Their first job isn't to guess where a storm is going. Nope. It's to gather the objective facts. What's the wind speed right now? Where are the clouds moving? Exactly how much rain is falling? They are simply describing the situation as it is. That's it. Now, to describe behavior like a scientist, you need the right tools. We use what are called operational definitions, which just means we define the behavior so precisely that two different people would see the exact same thing and record it the same way. We also look at its topography. That's just a fancy word for what the behavior physically looks like. And then we quantify it with hard numbers. How often does it happen? How long does it last? How intense is it? Okay, so once we have a really solid description, we can start climbing to the next rung, prediction. This is where we start figuring out the when. At this level, we basically become pattern detectives. After we've observed for a while, we start to notice that two things tend to happen together. There's a term for this, covariation. If event A happens, we start getting a pretty good hunch that event B is going to follow. We can actually start to anticipate behavior. Let's go back to our meteorologist. With all that descriptive data they gathered, they can now make a forecast. They've seen this pattern before. When this specific kind of pressure system moves in, a storm almost always follows. They can now predict the storm's most likely path. But, and this is probably the single most important takeaway from this level, so listen up. Correlation does not equal causation. Just because the wind and the rain happen together doesn't prove the wind is causing the rain. This is a classic scientific trap. It's the whole reason people might think ice cream sales cause shark attacks. They don't. There's a third factor, summer heat, that's causing both. Avoiding this trap is absolutely critical. And that brings us to the very top of our ladder, the highest level of scientific understanding there is, control. This is where we finally figure out the why behind a behavior and, just as important, the how to make a real change. Now, in science, control isn't about being bossy. It means you've demonstrated a clear cause and effect relationship. We call this a functional relation. You systematically change one thing, that's your independent variable, and you see a direct, reliable change in the behavior you're studying. That's your dependent variable. Okay, our analogy gets a little sci-fi here, but it illustrates the point perfectly. Scientific control is like the meteorologist not just predicting the storm, but actually deploying some device that changes the wind and steers the storm away. They are actively, successfully influencing the outcome. That is the ultimate power of scientific control. So let's put these two ideas right next to each other, because really, understanding this difference is everything. Prediction is like noticing two people on the dance floor are moving perfectly in sync. Control is proving that you're the choreographer leading the dance. One is just observing a pattern. The other is proving you're the cause. Now that we've climbed the whole ladder, let's turn all this theory into practice. I'm going to give you a few quick takeaways to help you lock this in and steer clear of some common mistakes. Need a simple way to remember the order? Here's a quick one for you. DPC. Just think of the phrase, do people comply? Description, prediction, control. Simple as that. Or, hey, if questions work better for you, try this framework. First, just ask, what is happening? That's your description. Then ask, when does it happen? That's prediction. And finally, the big ones. Why is it happening and how can I change it? That's control. And for anyone studying this, please watch out for these common traps. We've already hammered home the whole correlation versus causation thing. And remember, just describing something doesn't change a thing. Real control means you've ruled out all the other possible reasons for the change. And finally, real behavior analysis uses objective data, not just what someone says they did. So let's end with the ultimate goal. Reaching the level of control means you can stand there and say with total scientific confidence, this change happened because I did this, not because of chance, not because of the weather, and definitely not because Mercury is in retrograde. That is the real power of this science, moving beyond just guessing and hoping and into the world of creating real, predictable, positive change. Thanks for climbing that ladder with me.